Hey, welcome back. I'm so excited about this one, as you should be, since we're starting to transition from somewhere in the beginner level of understanding quadratics to a more intermediate level. We're making that transition. What that means is we're not quite beginners anymore. We're not at the basic level. And it means that we're also not at the intermediate level of understanding quadratics, but we're somewhere in between. So in other words, the problems are no longer very basic. Look at what we have right here. We have three equations involving parabolas, or three quadratics. And remember that I'm going to give you some prerequisites to move on from here. All right. If you don't understand what I'm saying, then you have no business being here. Watch previous videos. But you should be able to understand the three forms of quadratic equations that we've been exploring so far, which are, one of them is vertex form. The other one is x-intercept form and y-intercept form. There's previous videos with this title, so go check them out if you don't know what I'm talking about. And in this video, we're going to give them their formal names because that's not what the textbook refers to them as. So that's one of the main goals for this video. And the other thing is that hopefully not only do you recognize what the three forms of the quadratic equation are, but if once you do that, are you able to sketch and label 5 points on the quadratic? All right, so let's apply that. Take some time now. See if you can identify not only the form of each of these three quadratic equations, but label their 5 points on each graph. If you want to pause it and take about 15-20 minutes, that's probably how long it should take you to do all that. Go ahead and do that. If not, check with me now if you just want to see how I do it as well. All right. The nice thing about letter A, identifying the quadratic form of each equation, is that you don't have to remember three different cases. You could ask yourself the same questions for all three of them, and then you would figure out what the form of quadratic equation is. And the question is, what's easiest to find in this form? What's the most convenient thing to find? Let's start with this one. It's three options, either vertex form, y-intercept, or x-intercept. What's the easiest to find in this form? And that's right, it's the x-intercept. So I'm going to write that actually here. This is x-intercept form. Oh, I don't like that, but I know how to fix that. It's the x-intercept form. All right, let's look at the equation to the right of it. What is easiest to find in that form? You think about it, and that's right, it is the vertex. It is the first form of equations that we work with. So this is vertex form. That's like lesson 2 or 3 of this series, episodes 2 or 3 or something, maybe even 1. And then the next one is it's not in x-intercept form, it's not in vertex form, it must be in y-intercept form. And that's because the y-intercept is the easiest thing to find in this form. You just plug in x equals 0. X equals 0 to this equation means the y-intercept 60. X-intercept form means you plug in y equals 0, so you get x equals 3 and x equals -7. And vertex form happens when the something squared is equal to 0. So the vertex is -6, comma -16. And if you identify that, now let's see if you can graph those 5 points. And again, I'm just going to write this again. Do you remember what form this was? If not, you're in trouble. This is vertex form. But what's different from all the previous videos we've done now is now there's a vertical scale, an a term or a factor of a. And we know that it is a fraction. Is this fraction greater or equal to 1 in absolute value? Because it's less than 1, then we know that, can we think, is this a vertical stretch or a vertical compression? That's right, because it's less than 1, there's a vertical compression. So let's start to write some things. We know that x-intercepts, I'm sorry, this is vertex form, right? So the vertex, as we said before, is -6. When the something squared is equal to 0, we get a y value of -16. Then I would probably find the x-intercepts. And you also should know how to do this by now. What's true about all the x-intercepts, is that their y value is 0. Therefore, we can say that 0 equals 1 over 4. That's a vertical compression of the quadratic that we have. All right, next thing is we still want to think like before. Let's undo the minus 16. So 16 equals 1 over 4 times something squared. We want to turn it into 1 times something squared, not 1/4. So remember that 1 over 4 means dividing by 4. How do we undo that? I'll show a little bit of more work here. Let's multiply both sides by 4. So that on the left side, 4 times 16 is 64. And 4 times 1/4 is 1. That's why we chose that factor of 4. Times something squared. Oh, that's a 6. Nice catch. I caught it. Some of you are probably confused because I did that. It's plus 6 as the something square. X plus 6 is the something square. And therefore, I don't like the way that looks. Let me rewrite it. That way you can take more time to think about what was going on here if you need it. We have 1 point. We're going to get 2 more. And from here, I want to skip the step. Take your own time to figure out how I get at x is equal to a negative 6 plus or minus 8. We undo the plus 6 by subtracting it. The two numbers that we squared over 64 are positive or negative 8. There we go. So we can write this as negative 14, comma 0. Remember that the y value was 0. And the other x-intercept is a negative 6 plus 8 gives us 2, comma 0. Let's start plotting these 3 points we have so far. And then the rest of the picture is going to start to show itself very quickly. So we have 2, comma 0 somewhere here. And negative 14, comma 0. We know this is curving upwards because it's positive 1/4, not negative 1/4. That's kind of nice to know. Next thing we want to figure out is what is right in between these two, negative 14 plus 2. And guess what? It better be a negative 6. Negative 14 plus 2 is negative 12. So therefore, x is equal to negative 6 as the line of symmetry. And at that point, at that line, the y value, which is the lowest, is negative 16. And hopefully we can visualize this parabola that passes through that x-intercept, reaches its lowest point at the vertex, goes through a negative y-intercept, and then through positive 2. Can we figure out what this y-intercept is now? And then we will be done. We got vertex, 2 x-intercepts, and a y-intercept that's missing. But we know its x value is 0. So let's do that. Y-intercept happens, the parabola happens to cross the y-axis when x equals 0. So therefore we have y equals 1 over 4 times 0 plus 6 squared minus 16. And hopefully you can see that y equals 1 over 4. 6 squared is 36 minus 16. Be very careful. You might make the mistake of subtracting before you multiply or divide. In this case, we got to divide by 4. So 36 divided by 4 is 9. Minus 16 is y equals negative. Oh, wait a minute. Negative 7. Yep, that works. I was checking in my head for a long time, but it's okay if I pause because that gives you more thinking time. All right, next. The last point should be not difficult to get, and I'll use color if you forgot. This distance is equal to that distance. Therefore, what should that point be? That's known as the point of symmetry or the matching point because the y value matches. This should be a negative 12, and I hope I figured out in my head that you're able to do that from now on. And that is an example of vertex form. Vertex form worked out. What's convenient, and the nice thing is it doesn't change. The textbook actually does call it vertex form. And here's the main equation for it, all right? You ready? Here's what you should know about it. And this is the actual formula, which I don't like to start with, but I will refer to this a lot unless I'm trying to find the equation like in the previous video. Y equals a times something squared plus some value of k, some constant. And what's inside is x minus h, because it's always the opposite. The reason why I didn't write x plus h is because we always take the opposite to find the vertex. So if it is in that format, we know that the vertex is h comma k. That's why this is very powerful, because the vertex is the most convenient. Vertex is easiest to find here in this form. That's what it's called, vertex form. And that's what I was saying earlier, that unfortunately they don't call this x-intercept, and that makes me a little bit sad. But it makes sense why they call it what it is. So let's find out what we know as, do you recognize this as y-intercept form or x-intercept form? What's easiest to find here? It is the x-intercept, therefore this is x-intercept form. This is x-intercept form, but the textbook doesn't call it that. So let's write its name later. But the main thing is not that you know its name of the form, but rather can you plot the equation and label 5 points? So let's do that. Because it's x-intercept form, I'm going to start with x-intercepts in this case. X-intercepts occur when the y value is 0. That should be automatic for us by now. And that means that y equals when, whoops. That means that 0 equals 2 times something times something. X minus 3 is the first one. X plus 7 is the next. And the idea is, what makes 2 equal to 0? 2 could never equal 0, but can the next term factor be equal to 0, x minus 3? That's when x equals 3. The y value is 0. Or the other x-intercept is when the next factor is equal to 0. What makes this equal to 0? When x is negative 7. Then we have a 0. So I can start plotting those 2 points. We have negative 7 and 3. The line of symmetry should be somewhere in the middle of those two, but when x is negative. And we can figure that out next. So that's what I would try and target next. It is the vertex. But when does the vertex happen? We're not sure yet. Let's do the midpoint. So 3 comma 0, what's right in between 3 and negative 7? We do the midpoint, negative 3. Negative 7 plus 3 is negative 4 divided by 2. We know the midpoint is at negative 2. This is curving upwards because the a term, in this case, it is a vertical stretch. We know that because the a term is greater than 1 is positive. Therefore, this should be curving upwards. Now we want to know what the vertex is when x equals 2. Great. So we can plug it in the factor form, which is my preference. And now we can say it's 2 times something times something. But if we have 2, if we're plugging in a 2, we have 2 minus 3. 2 minus 3. 2 minus 3 is negative 1. And then we have 2 to the next factor. 2 plus 7. That's 9. However you choose to simplify this, this becomes negative 2 times 9, negative 18. Oh, it's positive. Wait a minute. X is negative 2. I made a mistake. Let's fix that. It's all right. That gives us more time to think about it and check your own work. When x is negative 2, let's redo that pretty as fast as we can. Negative 2 minus 3, negative 5. And negative 2 plus 7 is positive 5. And however you choose to simplify that, that's negative 50. Cool. So negative 2, negative 50 is the vertex. We know that it crosses the first x-intercept right there, reaches its lowest point, crosses the y-axis when it is a negative value, and then the x-intercept is positive on the right side. Now we need to figure out this point. Remember, the x value is 0, and we're almost done. We know that for y-intercept, x is equal to 0. So therefore, y equals 2 times something times something. And this is pretty easy. 0 minus 3 is negative 3. And 0 plus 7 is 7. So the y value should be negative 42. Therefore, the point is 0, negative 42. And we can figure out the matching point of symmetry to the y-intercept, which is negative 4, comma 42. There's an example of what we call x-intercept form. But remember that the textbook will not refer to it as x-intercept form, or ever advertise that it is easier to find the x-intercepts. So I meant to write x. X-intercept form, we will now know it at, instead of that, we will now start calling this factored form. And that's perfectly fine because we are given it to us, it's given to us in factored form. Factored form should look like y equals now some vertical scale factors times something times something. And it's usually like a x plus, my bad, it's usually the opposite, just like the last example, x minus the first x-intercept, and then x minus the second x-intercept. That's a subscript, by the way. It's not x to the first, it's x sub 1, but I'm referring to this as the first x-intercept, or one x-intercept, and this is the other x-intercept. And what's easier to find in this form? X-intercepts, that's right. Cool. That's the main important thing about this form. And there's an example of it. Lastly, we have the one that we're going to see the most often because it requires more work. It's not given to us in factored form, so we got to do a lot of factoring here. And as you know, the remaining one is y-intercept form. Now we're going to give it its actual textbook name right now, soon. But the easiest thing to find here is y-intercept. And that happens when x is 0. When x is 0, we get a 0 plus 0 plus 60. You figured out how I did that really quick because that's why it's convenient. 0 comma 60 should be the y-intercept. Look at how easy that was. For the vertex or x-intercepts, I'm sorry, I'm going to do that next. We have to do a lot more work. But the y value is still 0. We just need to know how to factor, which is why we spend so much time factoring and solving equations with a term greater than 1. Now I'm going to rewrite the equation so you have more thinking time. What is the greatest common factor of all of these three terms? Hopefully you think and realize, oh, it's a 5, but it's not just 5, it's negative 5. Due to the fact that the a term is negative. And then we're going to write negative 5 times something. Remember that factoring some form of division? So I like to think of it about it like this. What's negative 5x squared divided by negative 5? It is positive x squared. What's positive 20x divided by negative 5? It's negative 4x. And what's positive 60 divided by negative 5? It's negative 12. And now we can ask ourselves, all right, we have 0 equals negative 5 times something times something. What are two terms that can multiply to a negative 12, combine to a negative 4? It must be some form of 6 and 2. Only if 6 is negative and 2 is positive. If you don't know how to check that, please practice some more. Therefore, we know that x-intercepts, I'm just going to skip that and go to the point. It's 6, 0 and negative 2, 0. That's the way I'm going to write that. Take some time to check them for yourself. And as you're doing that, I'm going to start plotting these points. We have negative 2, 0 and 6, 0. Negative 2 and 6. We want to know the midpoint between those two. We know the y-intercept is way down here. I think I made a mistake. Let's redo this. And that's what happens if your algebra, and the way I knew I made a mistake is because my graph was not matching what I see with my points. So something makes me think that I made a mistake. And remember, every time I make a mistake, it's just an excuse to give you more time to think about what you got to do in this problem. So let's start with negative 2 and 6. One thing that I saw my mistake. I ignored the negative 5a squared. So I was trying to draw a positive parabola when rather it should have been a curving down parabola. Something like this. There we go. This is the negative 2, 0. Nice. Now it's starting to make a lot of sense and this fits the puzzle very nicely. This is 0, 60. There we go. And we can easily find the midpoint between negative 2 and 6. Let's find out what that is. So vertex is located at the midpoint of that. What is that? When x is 2. 6 minus 2 is 4 divided by 2 is 2. And I like the factored form the best. You can plug it in here and get the same answer, but just know that plugging it into the factored form is much easier in terms of calculation. So we can say that the y value of the vertex is negative 5 times, when we substitute a 2 for this x, we get 2 minus 6. 2 minus 6. What's 2 minus 6? It's negative 4. Then we're going to take the same 2 and plug it into this factor. What's 2 plus 2? 2 plus 2 is 4. So therefore, however you want to simplify this, we get a y value that is positive, and it is 80. Positive 80. 5 times 4 is 20. 20 times 4 is 80. But the point is 2, 80. Because x was 2. And there it is, 2, 80. And the point of symmetry right here must be a 4, 60. We have 5 points labeled. And there it is. All right, that was a lot of fun. We have pretty much combined every idea, every skill that we learned up to this point, to this video. And we're going to do 3 more examples of this in the next 3. However, we're just not going to write the form every time, but we do have to formalize this one. So this was the y-intercept form previously. Now we're going to refer to it as standard form. That's what they call it. And later when you study polynomials, you would know and understand why they call it standard form. Right now, it doesn't make sense. Y-intercept form is more convenient. But just know that that's the most convenient thing to find. Very convenient. All right. And the formula for it is y equals some stretch factor a times x squared plus b times x plus c. Notice that that's what we had here. This is a, -5. This is b, +20. And this is c, +60. There it is, the standard form for quadratics. And they are formalized. In the future, I will still refer to them as y-intercept form, x-intercept form, but let you know that they're the same as standard and factor form. Vertex form stays the same either way, so that's cool. Oh, wow, that's pretty cool that we've done so much math this far. Remember that we're starting to just enter the waters of intermediate level math understanding of quadratics. And I hope that you make it to advanced at some point because I'm ready to show you all that. Cool. But for today, that's it. Go enjoy the rest of your day. Go eat some food, go for a walk, go skate, watch more math videos, do your own practice. But either way, make it worth it. Cool. Bye-bye.